Welcome to the ultimate episode of the Science Channel's 100 Greatest Discoveries series. I'm Bill Nye, and these are some of the resident fossils here at the spectacular Hall of Dinosaurs here at the Carnegie Museum of Natural History. As you may know, in just 8 hours, we covered 100 of the greatest discoveries in biology, physics, chemistry, medicine, genetics, geology, astronomy, and evolution. Over the last few centuries, humans have made a lot of scientific discoveries, breakthroughs in our understanding of the world around us. So you might wonder, what made these the 100 greatest discoveries, and who picked them? Well, the folks at the Science Channel are who, along with university professors, researchers, and experts from scientific societies. Then you might wonder, what makes someone an expert? That's hard to say, but for this episode, you are the expert. See, since we started doing this, people have asked, which of these 100 great discoveries is number 1, or number 9, or 99? Well, with the help of our friends over at Discover Magazine, we put the question to a vote. We asked you to rate which discoveries you thought were the top 10. And now the ballots are in, so lean forward and turn it up loud as we show you what you picked as the 10 greatest of the greatest discoveries in science. We're counting down the top 10 greatest scientific discoveries. The mathematical nature of a countdown renders the first discovery that we count down as the 10th discovery of those on the list. See, it's a count down, not a count up. Anyway, it's our first one, and I can sum it up in 2 words: Isaac Newton. You see, it was the famous, the venerable, the incomparable Sir Isaac, whose genius contributed immensely to the advancement of our species' understanding of the world around us. Now think about it. It's quite a leap of imagination to realize that when an apple falls out of a tree, not only is the earth somehow pulling the apple down, but the apple must also be ever so slightly pulling the earth up. And Isaac Newton was the first one to understand that. But you viewers, in your wisdom, didn't want that. You weren't charmed by gravity with its inverse square, tiny invisible pull that is somehow large enough to control not only specks of cosmic dust, but entire galaxies. No, sir, Isaac. You went with another amazing set of Newtonian insights: Newton's laws of motion. To many people, Sir Isaac Newton is physics, and it's largely because of a series of 3 books he wrote which contain Newton's second great discovery, the laws of motion. The laws explain the movement of all physical objects. To help understand the 3 laws of motion, consider ice hockey.
It's simple enough. You hit a hockey puck and it just keeps sliding off across the ice. You can see that on a frictionless surface, it'll just pretty much keep going indefinitely. When you hit your stick against the puck, it accelerates it, and the nature of that acceleration that gets it from being standing still up to speed is explained by the second law, or rather you can calculate it using the second law. The third law says that when you hit the puck with the stick gets the force equal and opposite to the puck, or to put it another way, if one of the hockey players punches the other one in the face, he's as likely to break his knuckles as the other guy's jaw.
Newton's laws of motion were a bold insight into the mechanics of how the universe works. They established the foundation of what is now known as classical physics. Your pick for discovery number 9 keeps the focus on the invisible, microorganisms. In the early 1600s, basic microscopes were in use throughout Europe. Gentlemen scientists were held spellbound by their ability to enlarge the universe of the very small. Then in 1665, an English scientist named Robert Hooke observed the tiny boxes in a sliver of cork and called them cells because they reminded him of the small rooms lived in by monks. Anton van Leeuwenhoek was a Dutch merchant fascinated with science. Upon learning about Hooke's microscope, he decided to build one for himself. Dr. Gall. To find out what happened next, I paid a visit to Joseph Gall, a cell biologist at the Carnegie Institution in Baltimore, Maryland. Antoine Leeuwenhoek, what did he discover?
Well, Leeuwenhoek discovered quite a few things, but what he's most famous for are discovering protozoa, that is small single-celled animals that live in pond water.
How did he do that?
He did it using a microscope of his own construction. And would you like to see?
Oh, yes. You have a Leeuwenhoek microscope?
Well, not an original. I have a replica of a Leeuwenhoek microscope. It consists of two brass plates with a small piece of glass, which is the lens. And the way you use this is to put the specimen on the pin here, and then you hold your eye up very close to the lens on this side, and when you do that, you can see the point of the pin, and you can put the specimen, whether it's an insect or whatever, on that pin. Would you like to take a look at it?
Yeah. It's kind of heavy because it's brass.
Well, it's brass. He made them
In 1675, Van Leeuwenhoek was using his microscope to examine a bead of water when he observed something extraordinary. A world filled with creatures that no human had ever seen. Microorganisms. And so with this, with all due respect, primitive gizmo,
yes,
he discovered single-celled animals,
exactly.
things we take for granted
yes.
now.
What he's most famous for are discovering protozoa, bacteria, and sperm.
This thing is brilliant.
It's got a mechanical stage, it's got a focusing device, it's got all of the things that you need to look at a specimen. And it works.
Did they know what they were seeing? Do you know what I mean? Like, did they understand?
Well, I doubt that they really understood what they were seeing in the modern sense, but they were impressed that all these little things that were alive in water. I mean, people had no idea that water was teeming with organisms.
I guess I just had no idea the thing was this small and delicate, and frankly, so elegant, because it's palm of your hand, and what you see on the tip of that pin changes the world.
It does, indeed. It was an enlargement of our understanding of the nature of the natural world, that the world out there was not just dead things, but that it was teeming with life.
If you're like me, and I know I am, you might be dead today if it weren't for antibiotics. There have been a few times in my life when I was sick, and these molecules helped me win a battle with a disease. You chose the most famous one. Perhaps it was the easiest one to find, to discover, because it's so potent. At any rate, penicillin changed the world. And I, for one, am glad you chose it. World War I, more than 10 million dead, many from the infection of their wounds. After the war, research intensified to find safe methods of repelling the bacterial invaders. Among those on the case was Scottish physician Alexander Fleming. While studying Staphylococcus bacteria, Fleming noticed something unusual growing in the culture dish, a mold, Penicillium notatum. He saw that the bacteria surrounding the mold had died off, which led him to speculate the mold was producing a substance that was lethal to the bacteria. He named the substance penicillin. For the next several years, Fleming tried extracting penicillin and applying it to treat infections. But he was unsuccessful and eventually gave up. Fleming's work, however, proved invaluable. In 1935, scientists Howard Florey and Ernst Chain at Oxford University came across a record of Fleming's curious but incomplete work with penicillin and decided to investigate. This time they successfully extracted and purified penicillin. And in 1940, they tested it. They injected 8 mice with lethal doses of the bacteria Streptococci. Then they injected 4 of the mice with penicillin. Within hours, they beheld the results. The 4 mice not treated with penicillin were dead, but 3 of the 4 that had been given penicillin were alive. From Fleming to Florey and Chain, the world's first antibiotic was born.
It was a miracle drug. It cured so many diseases that had caused so much pain and suffering. Strep throat, rheumatic fever, scarlet fever, syphilis, and gonorrhea. It was things that we wouldn't even think about today should kill you.
With your next pick, you stayed on the disease theme, germ theory. Some discoveries, like X-rays, seem to come out of the blue, while others, like our next great discovery, develop over time, with one scientist contributing to the work of another. Vienna, 1846. A city of beauty and culture. But at Vienna General Hospital, there was the specter of death. Many of the women who came here to give birth were dying. The cause? Childbed fever, an infection of the uterus. When Dr. Ignaz Semmelweis came to work at the hospital, he was alarmed at the scope of the problem and intrigued by a curious discrepancy.
They had 2 wards. In one, the mothers were delivered by physicians, and in the other, the mothers had their babies delivered by midwives. Semmelweis noted that in the ward where the physicians delivered babies, 7% of the mothers died from what was called childbed fever. In the ward where the midwives delivered, only 2% of the mothers died from childbed fever. And this bothered him because physicians have more training. They're supposed to do better by their patients.
Semmelweis was determined to find out what was going on.
He noted that one of the main things that physicians did that midwives did not do was to conduct autopsies on these mothers after they died. Then they would go back and deliver babies or examine mothers without washing their hands, just like an auto mechanic who would finish up on one car and then move to the next car without washing his hands to get the grease off. He didn't see any reason to have to do this.
Semmelweis wondered if the doctors were carrying some invisible matter on their hands, which they passed on to their maternity patients, causing them to die. To find out, he conducted a test.
He decided that he would have the student physicians under his control wash their hands in a chlorine solution. And suddenly, the percentage of maternal deaths dropped to 1%. That's lower than the midwives.
With this demonstration, Semmelweis realized that infectious disease, in this case childbed fever, has a single cause. If you eliminate the source of the infection, the disease does not occur. But in 1846, no one had made the connection between bacteria and infections. As a result, Semmelweis's idea was ignored. It would take 10 more years before another scientist would turn his attention to germs. His name? Louis Pasteur. Pasteur had lost 3 of his 5 children to typhoid fever. which perhaps explains why he was determined to find the cause of infectious diseases. It was Pasteur's work on behalf of the beer and wine industry that put him on the right track. Pasteur was trying to find out what was spoiling so much of the country's wine production. He discovered that the spoiled wine was contaminated by microorganisms, germs, and the germs were causing the wine to sour. But with a simple heat treatment, he showed that the germs could be killed off and the wine saved. The pasteurization process was born. So when it came to finding the cause of infections and contagious disease, Pasteur knew where to look. Germs, he said, cause specific diseases, and he proved it through a series of experiments and demonstrations that led to his great discovery, germ theory.
The germ theory literally marks the beginning of modern medicine. The germ theory has one central idea, that one microorganism causes one disease in everybody. Now today this seems so obvious, but this is one of the most revolutionary concepts in medicine.
We inherit who we are. I know you were thinking about it because heredity is your number 6 greatest discovery. In the middle of the 19th century, an Augustinian monk named Gregor Mendel took up the question of biological inheritance with a series of experiments. Mendel had a naturally inquisitive mind and a profound love of nature. His scientific interests ranged from research on plants to meteorology and the theories of evolution. Working at a monastery in what is now the Czech Republic, Mendel started by crossbreeding different strains of garden peas, then observing the characteristics of their offspring. Why choose peas? He did it, he said, for the fun of the thing. Mendel noticed that when he crossed a round pea seed with a wrinkled one, the offspring were round, not a mix of the two characteristics as he had expected. Yet when he bred the round pea offspring, that's where the mix appeared, and the second generation had both round and wrinkled seeds. He continued to experiment, trying to understand what kind of biological mechanism would cause certain characteristics to disappear in the first generation, only to reappear in the second. Then one day, Mendel counted the number of peas in the second generation that had the wrinkled characteristic. Exactly 1/4 of the peas were wrinkled. What Mendel observed in his experiments were the biological phenomena we now refer to as dominance and segregation, only Mendel didn't know it yet. Still, his experiments produced a curious set of facts which, as he said, forced themselves upon my notice. You see, no matter how he crossbred the various strains of peas, the hidden characteristics showed up, but only in 1/4 of the second generation. For Mendel, here was the breakthrough. For the first time, he could demonstrate that the traits of successive generations were inherited in certain numerical ratios. In other words, there were fixed laws of nature that governed heredity. With this insight, Mendel made the first great discovery in the science of genetics. Each inherited characteristic must be decided by a pair of what he called factors. Each parent, he said, contributes one factor for each characteristic. Certain factors are dominant and others recessive, depending on the combination of the factors the offspring inherits. And Mendel's factors are called genes. The term Mendelian trait is used to describe a characteristic caused by a single gene that sometimes reappears in 1/4 of the offspring. That characteristic can be innocuous, such as freckles or the ability to curl your tongue. But it also can lead to serious illnesses like cystic fibrosis or Tay-Sachs disease. Imagine all that from one man's work with the humble pea. Welcome back. We're counting down your top 10 picks for the 100 greatest discoveries in science of all time. Well, all the time we could manage. The next one is so fundamental, so much a part of everything we see every day, that it is hard indeed to believe that it took us humans so long to come across this phenomenon. How could we not notice that the Earth is not the center of things? It and we are traveling through space. You see, the Earth moves. The year is 1543. A 70-year-old man is dying. His name? Nicholas Copernicus. A doctor and lawyer by trade, but for nearly 40 years he was also an amateur astronomer. A pursuit that had led him to challenge one of the most fundamental and sacred beliefs of his time. As a young man, Copernicus had studied the heavens and found that the Greeks' Earth-centered system failed when it came to predicting planetary motion. He began to wonder if the Earth itself moved.
But here is Copernicus's idea.
With the sun as the center.
The sun is the center, and now suddenly
All the planets
are going always the same way around. They're not stopping.
Copernicus realized that the movements of the planets were better explained if the sun were at the center of the solar system and the Earth circled it like an ordinary planet. It was a revolutionary insight.
Despite any evidence that the Earth was moving, he came up with this book, which gives his new theory.
This idea, this book, changed the world.
Yes, because it made the Earth a planet, and it fixed the sun in the center. If you don't have that blueprint, you don't march ahead to the physics of the cosmos. As it happened, the final pages, which were just these here in the front of the book, came to him on the very day he died. I suspect, he was lying there partially paralyzed from a stroke. He was probably just hanging in there till he could make sure that it was done.
Your pick for discovery number 4, the periodic table of elements. In 1869, a Russian chemistry professor named Dmitry Mendeleev was writing a textbook for his students when he began to wonder how he could best explain to them the 63 elements that were known at the time. To help formulate his thoughts, he constructed a card for each element. On each card, he wrote the name of the element, its atomic weight, its typical properties, and its similarities to other elements. He then laid the cards out like a game of solitaire and began arranging them over and over, searching for patterns. Then came the moment of discovery. Before him was something extraordinary. The elements fell into 7 vertical groupings. Each periodic grouping had members that resembled one another, both chemically and physically. Mendeleev had discovered the periodic table of the elements, a map showing how all the elements related to one another. A map so precise that Mendeleev believed he could also use it to predict the existence and properties of 3 elements no one had yet discovered. One would be like boron, he said, one like aluminum, and one like silicon. Eventually, the elements were discovered, and Mendeleev was proven right.
There was actually a little bit of controversy because a German chemist named Lothar Meyer had come up with roughly the same idea. But Meyer didn't quite have as much courage. So that's actually an interesting thing. Here is this German who comes up with the same idea of periodicity, of which there were hints already before, but he doesn't make the predictions that Mendeleev does. So here we see the power of a risky prediction in having people accept a theory. There is nothing more powerful than making a prediction that's not obvious.
And then have it come true.
And have it come true.
Yeah.
The periodic table is our icon. I mean, it's what we associate with chemistry. You go into any chemistry room, you see it.
Why is the periodic table of elements significant? It forever changed the way that everyone would learn and understand the elements. The periodic table of elements is to chemistry as notes of music are to a Beethoven sonata. In honor of Mendeleev, his name is now literally attached to the periodic table. The element 101 was named after him. It's called Mendelevium.
It's not only chemists who like the periodic table. I hear you carry one around.
I do carry one, yes sir.
Show me.
You never know. And I seem to use it a lot.
Let's see.
It's a small one.
So I'm going to give you a test. What is under nitrogen in the periodic table?
Nitrogen is 7.
Yes.
I have to think a second.
Under
sulfur.
No, you're wrong.
Oh, God. That's
Close.
why I carry
You're
the thing.
one off. It's phosphorus.
Oh, phosphorus.
Phosphorus
15.
is right.
Phosphorus is 15?
Yeah, you have to add 8 at that point.
See, that's why I carry it. I can't remember. So it's 7 plus 8, 15 phosphorus. Okay. There's a pattern there. I get it now. Welcome back to the Big Time Top 10 Countdown, drawn from the Science Channel's 100 Greatest Discoveries. You've rejoined at a perfect moment, just the right time. We're going to cover the man who first questioned the common sense perception of the steady and regular passage of time. It doesn't sail along swimmingly with no flukes in its flow. Now, time is somehow part of space. Swirling through our universe are fundamental forces, the counterintuitive nature of which were first grasped by the man for whom you assigned 2 consecutive top 10 spots, Albert Einstein. E equals mc squared, maybe the most famous equation known. Where did it come from?
Einstein used relativity to show that as you approach light speed, bizarre distortions take place. Time beats slower. Space contracts and you get heavier. The faster you move, the heavier you get. Now think about that. The energy of motion has turned into making you heavier. M came from velocity, energy. Here's how he did it. He imagined a flashlight shooting a light beam. He knew exactly how much energy came out of the flashlight. But the flashlight he showed weighs less. The flashlight weighs less by emitting a beam of light. Therefore, the E of light came from the M of the flashlight. And the ratio is c squared. That's how it's done.
The equation also hinted at the enormous amount of energy contained in even a small quantity of matter.
Suppose I throw a baseball at you, okay, and you catch it. The faster I throw it, the more energy it's got. Now, what about when it's standing still? Well, when Einstein goes through his equations, he finds even when it's standing still, there's a lot of energy in it. And in fact, when you do the equations, it's got an enormous amount of energy in it.
When a roller coaster is at the top of the hill, its energy of motion is almost 0, but it is still filled with energy, potential energy, which is about to be converted into huge energy of motion as the roller coaster comes screamingly down the hill. What Einstein said was that there is energy in the very pith of matter, that even a proton has within it an immense amount of energy.
Einstein's discovery was a gigantic leap for science, our first real glimpse into the power of the atom. Your second greatest discovery, general relativity. Thanks to the musings of an obscure clerk working in the Swiss Patent Office, our next great discovery revealed that the universe is a strange, mysterious place. That clerk was Albert Einstein. In the early 1900s, he was puzzled, along with the rest of the scientific community, by the orbit of the planet Mercury. Despite the ability of Newton's laws of gravity to precisely predict the motion of the planets, the laws failed when it came to correctly predicting Mercury's orbit. The puzzle had to do with Mercury's perihelion, that point in its orbit where it's closest to the Sun. Every century, Mercury's perihelion advanced slightly, a change that Newton's equations could not account for. In a bold and startling move, young Einstein proposed his own theory to explain the puzzle of Mercury's orbit, and in the process, developed a theory that refined Newton's laws of gravity. Michio Kaku is a theoretical physicist at the City University of New York.
Newton says that gravity travels instantaneously throughout space, and that's where Einstein thought there was a weakness in Newton's theory. He wanted a theory that could explain gravity. He wanted a theory that could explain acceleration and zigzag and circular motion. There has to be waves, gravity waves. It takes time for gravity to work its magic.
To propagate.
To propagate. So if the sun were to disappear, it would take 8 minutes for us to know about that fact. Even gravity travels at the speed of light. Einstein needed a new picture to explain that. And that picture was curved space. That space itself has curved, and that's why objects move.
Einstein believed that his concept of curved space was responsible for shifting Mercury's orbit. Einstein called his idea the theory of general relativity.
Imagine a trampoline net and place a bowling ball in the middle of a trampoline net. The bowling ball sinks into the trampoline net, and now shoot a marble around the trampoline net. The marble will orbit around the bowling ball. Now, from a distance looking down, Newton would say that there is a force, an instantaneous invisible force pulling the marble down to the bowling ball. But Einstein would say, there's no force. There's no pull, it's just a trampoline net. And why is the marble orbiting around the bowling ball? Because a trampoline net is pushing the marble. Therefore, why am I sitting on this chair? Not because gravity pulls you to the ground, it's because space pushes me down toward the planet Earth.
The idea that space itself was warped by mass was too strange for many to accept. An approaching solar eclipse gave scientists the perfect opportunity to put Einstein's new theory to the test. Photographs were taken of the background stars before the eclipse and then afterwards. These pictures were then compared with photos taken during the eclipse. The photos showed that the positions of the stars in the eclipse photo shifted slightly inward, bending as the light from the stars passed the sun's gravitational field. Einstein's theory of general relativity was right. His great discovery rocked the world.
General relativity strikes a deep emotional chord in anyone who's ever looked at these equations. These equations are 1 inch long, and yet they answer these eternal questions that have dogged us ever since we first looked in the night sky and asked ourselves the question, what's it all mean?
Now, before we push that big button in the control booth, before we vault up to that video viewer in the sky and on the cable, before we stop with this long introduction to the #1 great discovery in science so far, I just want to point out that this one is controversial. This one gets people's hackles a-hacking. No matter how you feel about it, bear in mind that our next #1 discoverer came across some things in nature that surprised him, and he tried to explain what he saw. It's not the story of a guy just trying to cause trouble. It's the story of the guy who made what you and I consider the #1 discovery in science so far: natural selection. In the 1820s, surgery was a grisly affair. There was no anesthesia, and young medical students were forced to watch and learn. The young man who walked out that day was Charles Darwin. The ordeal of the operating room was too much for him. Over his father's objections, he quit medical school to pursue his dream of becoming a naturalist. Darwin was hired as a naturalist aboard the British Admiralty's HMS Beagle, which embarked on an expedition to survey and map coastal waters around the world. The Beagle was at sea for 5 years. To Darwin, it seemed an eternity. He shared a small cabin with the captain, with whom he had several disagreements, including the story of creation. Darwin. While the captain held to the Bible's account of creation, Darwin believed that the earth had changed slowly over millions of years. It was a debate that would follow Darwin for the rest of his life. The British government paid for this?
No, actually, Darwin's father paid for his voyage and also paid for an assistant to come with Darwin and help him skin the specimens and prepare the crates for shipment. He worked in a little poop deck where he had all his specimens, just about something like this.
The Beagle made stopovers in ports from Australia to South America, including 36 days in the Galapagos Islands. And Darwin made the most of it. He recorded extensive observations about the indigenous plants and wildlife. He collected and preserved thousands of specimens for study. For years after the voyage, Darwin would recall the observations he made while aboard the Beagle.
It was not until 1837, a couple of years after he returned from the Galapagos, that he opened his first species notebook. And he asked himself the question, very ambitious question for a man in his late 20s. What are the laws of life?
Is this Darwin's whole point?
It was Darwin's whole point, to try to find laws operating in the natural world similar to the laws that physicists and chemists had found in inorganic nature.
Darwin's search to understand the laws of nature took shape as he studied the animals on the Galapagos Islands. Of special interest to him were the physical differences within a certain species. For example, the finches on the Galapagos had different shaped beaks. They varied according to the environments where the finches lived. Some had beaks that were hard and blunt, ideal for hammering open crab shells. Others had beaks that were more tapered and suited for hunting and pecking among rocks. The difference was puzzling. As Darwin analyzed it, he began thinking about how the struggle to survive was the driving force behind all life. If a species is to thrive in its environment, it has to evolve or perish. With this simple yet powerful insight, history was made. Darwin discovered the mechanism that made evolution work, the process of natural selection. Darwin wasn't the first guy really to come up with this, right? What was his special or particular insight?
He was the first to come up with a specific mechanism, that is natural selection. He was the first to popularize the idea of deep time, millions of years that this process involved. He was the first to popularize the idea of the tree of life, in which we're related to all living things. The great geneticist Dobzhansky once said, "Nothing in biology makes sense without evolution." Because biology today is evolutionary biology. That's what biology is all about, and has been all about since 1859. How we got here, what kind of creatures we are, how we're related to everything else in nature. It's been established we are all part of one great tree of life, plugged into a bloodline, to a DNA that links us to every living thing on Earth. That's not metaphorical. That's literal.
Why did it take Darwin 20 years to publish his ideas?
He knew there would be a storm of religious protest. His own wife was not happy that he was going to write things that were incompatible with the Bible. She wrote him a letter when they were first married saying, I hope that your science will not lead us to spend eternity in two very different places.
Wow.
And she was seriously concerned about this. Plus, he was trying to build up a mountain of evidence that would be incontrovertible.
Finally, in 1859, Darwin published his theory of natural selection. His book, Origin of Species, is considered one of the greatest books ever written. People talk about the theory of evolution, right? But Darwin was the guy that said, well, there isn't any absolute truth here.
Darwin, being one of the first modern thinkers, tried to tell us that science is provisional. It changes.
What do you mean by provisional?
It means it's the best truth you have at the moment. And when you get more data that can't be explained that way, then you have to get a new theory. So it's not an eternal truth. It's a provisional truth. It changes. And he did not want evolution to be accepted as a dogma or a creed. He would have been the first to say, throw it out if you got something better.
But we didn't find anything better.
We didn't find anything better. In fact, what we found was that entire new sciences that were undreamed of in Darwin's day have come up through the study of molecular genetics and DNA, which reinforce the idea of evolution, so that now, everywhere we look today, we see something that came from Darwin in science.
There we have it, your top 10 of the greatest discoveries in science. Now, before you get all arms akimbo about a particular favorite that didn't make it, let me say, I feel your pain. Look at this list. Do you see electromagnetism? I mean, for crying out loud, without that, right now, I wouldn't be here on television and you'd be doing something else. What about those big things like tectonic plates and the Big Bang? No plates, no jostling Earth's crust, and no us. No Big Bang, no universe as we know it. Your short list dissed, omitted, those discoveries too. Most of all, I miss having this story in the top 10. A woman comes up to Michael Faraday after one of his lectures about electromagnetism and asks him, but Mr. Faraday, of what use is it? And he's supposed to have said, Madam, of what use is a newborn babe? I mean, how prophetic, how forward-thinking, how brilliant is that? I mean, newborns aren't very useful. They're loud, they leak, but still, you never know. You just never, ever can really be sure what they might become. With babies and electromagnetism, it's all about potential. And I leave you with that. I hope you enjoyed our journey. It was fantastic for me. I met such intriguing people, researchers, science historians, and Nobel laureates, all of whom love science and know the joy of discovery. Each of these discoveries, and the countless other insights that added to our understanding of the world, is worthy of more description than we could give it here. But here's hoping you'll give them all some thought as we continue to explore, understand, and discover. Go wild. Bye.